So there are times that they actually give me a function. This one is f of x equals 9/5 x plus 32. Remember, it's like y equals 9/5 x plus 32. To be able to convert from degrees Celsius to degrees Fahrenheit. So what they want me to do in this case, f of 15 means the 15 is in place of the x, so I'm going to substitute 15 in place of x here. Now here's what I want to see for your notation. It's okay on your work step to put 9/5 times 15 plus 32. And then in this case, because I can show this work, 9/5 times 15, well, 15 divided by 5 is 3, times 9 is 27. I could also do that in my calculator. I'm putting this step down. What I absolutely have to see from you is this substitution step before you give me your answer. And so my final answer, I want to see f of 15 equals 59. So don't forget to put this notation in your final answer. Minimum work, substitution step, answer. So f of negative 10 means I'm going to take 9/5 times negative 10 and then add 32. And again, minimum work is to go down then and say, well, f of negative 10 equals, well, negative 10 divided by 5 is negative 2, times 9 is negative 18. Negative 18 plus 32 is 14. So at a minimum, I need to see this. Now in this case, they're not giving me a value of x to put in for x. They're saying, hey, when f of x, which is y, when that equals 41, what x value would I have to put into this equation to get this as my answer? So what I need to do is to set up the equation 9/5 x plus 32 equals 41. So I don't know what x is, but I know it's when this whole thing equals 41. To solve this, I would subtract 32 from both sides to get 9/5 x equals 9. And then at this point, you need to either, because it's 9/5 times x, divide both sides by 9/5, or multiply by the reciprocal of 5/9. So if I'm just going to show it as divide by 9/5. Again, it's the same thing as multiplying by 5/9. So x equals 5 would be my answer. In order to get f of x equal to 41, x itself would have to equal 5. Now, this one says, hey, what x value would I have to put in there now to get f of x equals negative 4? So when does 9/5 x plus 32 equal negative 4? Again, I would subtract 32 from both sides, so I'd have 9/5 x equals negative 36. At this point, instead of dividing by 9/5, I'm going to multiply both sides by 5/9, just to show it's really the same thing. So I'm going to multiply this side by, 5/9. And the reason I do that is because this would be 45 over 45, which is just 1, and multiply this side by 5/9. Remember, this is negative 36 over 1. So this side becomes x. Negative 36, I could multiply it by 5 and then divide by 9, because 1 times 9 is just 9. Easier to divide by 9 first. Negative 36 divided by 9 is negative 4, times 5 is negative 20. So if I put negative 20 in for x, my f of x, f of negative 20 is negative 4. Again, in this case, you do need to set up these equations and show me at least the amount of work that I have here. So they're asking me to define a domain and range for a function, in this case from a graph. You've defined domains and ranges from tables. Remember that your domain is your input, which is on your horizontal axis. And I don't know why I put a T on that. That's kind of silly. Domain. Well, in this case, it's the set of all of the x values. And these are distinct points. It's not like all connected together in this curve or all connected together in this line. So it would be negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, as I look through those. 1, 2, 3, 4, 5. And my range is all of my y values, the ones on the vertical axis. Well, they go from 0 up to 5. I don't have to put, there are two different 5s, I don't have to put both of those. I put them in order, 0, 1, 2, 3, 4, and 5. Again, in order, no repeats. So that's for A. For B, give myself a little bit of room here. This is a curve, so it's not like just 0 and this would be 45, 90. These aren't just distinct points. These are all together. So I have to do a compound inequality to say what's happening with my x values. My domain, and I do need to label which one's which. X is between 0 and 360. So 0 is less than or equal to all of the x values on this curve, and all of these x values are less than or equal to 360. My range is all of my y values. Well, again, it's a curve, so all of these points in between are there. It goes from negative 1 for my lowest y up to positive 1 for my highest y. So negative 1 and positive 1, my y is between those. Negative 1 is less than or equal to all of my y values, and all of my y values are also less than or equal to positive 1. For C, what's shown on the graph ends at about 15, negative 15, and about positive 15. But because of these arrows at the ends, notice that there was no arrow at the end, so this did not continue. It was just this part, and that was it. These arrows mean that it continues on forever. So if the domain is all of the values for x, well, as I keep going to the left and to the right on this line, I'm going to eventually hit every possible x value. So in this case, the domain is all real numbers. The range in this case is also all real numbers because there's some vertical movement up and down on this line that goes on forever. So the range is also all real numbers. Now, sometimes you're going to be asked to look at things in real-world context for domain and range. So the amount of money that Jennifer makes in a week depends on how many hours she works. So her independent variable, or her IV, is number of hours worked. And her dependent variable, DV, is weekly salary. Now let's think in terms of, again, what's reasonable. A domain. And I'm going to use just x and y for these variables as well. My domain. She can't work under 0 hours. She could work 0 hours. So x has to be more than 0. And at the absolute most, if you take 24 hours a day times 7 days a week, there are 168 hours in a week. Now, obviously, she can't work 168 hours. So, but there are people who work 80 hours a week. Sometimes if they really, really, really end up kind of in dire straits and there's a project due, they could work 100 hours in a week. So I would put something here. 0 is less than or equal to the number of hours she worked. And granted, most people don't work over 40 to 50 hours, but let's say that if she's really, really, really pushing something, she might work up to 100 hours. I can't even imagine having to do that often. The range, well, how much money would she make? Well, she can't make less than $0. And if she gets paid a weekly, an hourly salary, which apparently is what she does. What's a reasonable amount for the salary she would make? Let's say she makes a fairly good salary. She makes $30 an hour. Well, if she worked 100 hours, then that would be $3,000. These upper limits are probably pretty high. But if we make those assumptions that she could earn a nice salary, probably not that much. She could work a ton of overtime in 1 week, again, probably not that much. These could happen. Now you might say 0 is less than or equal to x is less than or equal to 40 because a full-time job would be 40 hours a week. And then maybe you're saying she doesn't make $30 an hour because not a lot of people do. Doesn't make $30 an hour, so what would a reasonable salary be? These need to be somewhat reasonable numbers, though. Now, before you come to class, work on these. Remember, IV is the independent variable, DV is the dependent variable.